couple minutes to go. Again, we do the 15 minutes thing to give you a realistic perspective on the focus and attention you want to bring to it. So I think these final 2 minutes, I think this is good practice for you to consider what are some of the things you could do in those final 2 minutes to like squeeze out like one more point to show just a little bit more of what you know, that kind of thing. So again, we're just practicing. Just practicing. The first two here. So here is answers for A and B. So A. So listen, hey guys, what I noticed as I walked around, looked over shoulders, for A, a lot of you were setting up to try to find the average value of F. Like you had like 1 over pi times the integral from 0 to pi of F. And they didn't ask for the average value of F, they asked for the average rate of change. And so rate of change, you could always think of rate of change being synonymous with slope. So the average slope of F would be a difference quotient. You can see it right there, and you get the answer to that. Go ahead.
So couldn't you do the like I did like 1 over pi integral 0 to pi of F prime.
If you, yeah, okay, so of F prime.
Would you get this? I don't know, I didn't.
You should, yeah, you should, because to get F prime, you just differentiate F, and then you would know what the antiderivative of F prime was, right? So you just go back.
F and put over pi.
Exactly, and so I'm guessing at some point you would have been like, oh man, that's what I started with. What exactly did I just do? But you could get there. Yeah, you could definitely get there doing that. So I would say that shows some pretty good understanding. I was more concerned about the people who just did average value of F versus average value of F prime, which is what you described. So doable, but this would be more efficient. B, of course, F prime did come into play because it asked for the slope of the tangent line. So you had to do a product rule to get there. Nick's question was really good to talk about. He said, and I think maybe you got B right, and that's awesome. But Nick, I think, essentially got to here, and he said, do I have to go past that? And the answer is no. I don't think you should. It's not that you don't know how to get past that. It's just not worth your while. It's not worth your time and energy.
Can you check out that you...
Oh, like factor it out?
Yeah.
Of course. Yep, you certainly could. I don't see that there's any need to. To me, that would be even like one more step that you don't need to do. But there is nothing wrng with that at all. Okay, so there's A and B. Any further questions on A and B there?
Do you have to have a sense to bar?
No. I think if you've got F prime of 3 pi over 2 equals, and then the thing that it equals is the right number, I think we're good. Anyone else?
Yeah.
Oh.
A and B.
Never mind. So you only get the point on the first one if you get the answer.
Yeah, that's just straight up, did you get it or not?
Oh.
Yep. Yeah, they don't do like half points or stuff like that. Okay, so then here are the answers for C and D. I think we can, well, shoot. There's C.
It's that big. All right, fine.
Let's just talk on C real quick. We'll get to D in a second. So C asks for the absolute minimum. And so hopefully you had F prime and B, so all you did is you set that equal to 0. This is where unit circle came into play. You really had to solve that equation. You got 2 critical points, and maybe you made a table, right? This is kind of the standard approach we took in our class, make a table of values for F. And then they were really nice to us. We didn't have the calculator. Obviously, the output for 5 pi over 4 is the only negative number, so that would have to be the minimum, right? So, yeah, question, Bailey. No?
Wait, so is this mostly just like guess and like plug in numbers to see if it makes it 0? I'm confused as to how you
Oh, like how you would solve that?
Yeah.
Sure. So it's e to the x times cosine of x minus sine of x. So I'll just fill in a little bit of work here. Yeah, so you'd set that f prime equal to 0. So it would be e to the x, I already forgot, e to the x cosine of x minus e to the x sine of x equals 0. So it comes down to solving that, and you could do some guessing and checking, but there's a method you could use too. I would factor out the e to the x first. And once you have this in factored form, you'd set each factor equal to 0. We talked about this on some other question. The truth is that e to the x never does equal 0. But cosine of x minus sine of x equals 0. And I think that there are a lot of ways you could get at this. Like if you know your unit circle, you'd say, well, gosh, if this is true, wouldn't cosine of x minus sine, wouldn't cosine and sine have to be the same number for that to be true? So for what angles are cosine and sine the same number? You'd maybe think, oh my gosh, it's got to be one of those pi over 4 angles, right? And so maybe you'd say, okay, so in the first quadrant at pi over 4, they're both root 2 over 2s. Second quadrant, same number but opposites. Third quadrant, same number, they're both negative. So you could just sort of like, kind of like in the vein that you said, like educatedly guess and check your, I mean, please, for goodness sake, don't start off with 1,
Numbers, yeah.
1.3, that kind of thing. Obviously, unit circle would be the intent here. But then I think you could be more strategic about your guessing and checking by thinking what I was talking about. Here's another way. You could add the sine x to the other side. Then you could divide both sides by cosine of x. If I do that, I get 1 equals tangent. And then just ask yourself, for what angle is tangent 1? Goes back to the unit circle. First quadrant, third quadrant, where tangent's positive. We get to the all students take calculus, like you said. And eventually you'd end up with a pi over 4 and the 5 pi over 4 again. So I think a couple, 2, 3, 4, we could probably come up with more strategies if we had the time to solve that. But there certainly is a method to do so. Anyway, so yeah, if you could very conceivably get 2 out of 3 and struggle with those evaluations. Maybe, I don't know, maybe struggle with time, but that's how that one worked out. Any other questions on C? So D was the trickiest. Oh yeah. So I was actually a reader on this question. I've referred to this question before, I think, in this class about how, like, I would grade all morning long from like 8 a.m. till noon. And like, if I added up all the points that people earned on this, it would be like 4 all morning long, like tons and tons and tons and tons of zeros. The trick here is you had to really bring in the argument that because G is continuous at x equals pi over 2, you get the limit equaling 0. If you applied L'Hopital's rule, you could definitely get 1 out of 3. Eventually people started getting 1 out of 3s and all that stuff, but 3 out of 3s were super duper rare.
If you get the second 2, but you didn't say that it was continuous, do you get them or do you not? You shouldn't have applied.
So let me ask you this. How did you, the continuity thing, the short answer to your question is yes, you could get 2 out of 3. Yes. The question is, like, this is where people really had a sticking point. It was really frustrating to me as a reader because, like, I totally get why people could have just blown right on past that one. But the last 2 points, I'm like, come on, you can do this, that kind of thing. How did you show your L'Hopital rule? Did you show limit of top equals 0, limit of bottom equals 0? I think you're good then. I think you're good. So perhaps a 2 out of 3 then.
Yeah, and I don't have to write that it's that rule. I just need to show that the limit of top is 0.
You don't have to write the word L'Hopital. No.
Can I say,
'Cause I don't
like,
remember.
the L'Hopital's rule of conditions are met? Like,
Nothing wrong with that, as long as you actually showed. Like, you need to
like
show.
I did the limit of x of pi over 2 of g of x equals 0, and that of f of x is myself.
Yeah. So as long as you showed those 2 individually, that's the conditions being met. And then that allows you then to use L'Hopital's rule, and hopefully you used it correctly and you got this nice answer. But there were not very many people that showed those conditions correctly. A lot of people did all that other junk that I showed you in the past, and so they just got nothing. A lot of people, and I totally get it. I mean, it's so subtle because they tell you, hey, g is differentiable and g of pi over 2 is 0. And so it's so easy just to forget, oh my gosh, it's got to be a continuous function for this to actually.
So why is it 3 continuous?
So you could have a graph. So like, let's say this is a graph of g. And pi over 2, let's say, is right there. We know that g of pi over 2 is 0. But unless we're told that g is differentiable like we were, or g is continuous, we don't know what the behavior is, right? So very easily the behavior could be like this. And if that were the case, then while g of pi over 2 is 0, the limit as x approaches pi over 2 of g would not be 0. And so in order for this to describe the behavior of the function actually has to approach it. And the only way that that could happen is if you have a continuous function. We know that the function g is continuous because we're told that g is differentiable. So like I said, that's a subtle little trick, and I think you could be forgiven for not making that connection. It'd be awesome if you did, but I think it's subtle enough to where it'd be like, wow, that's really impressive that you got that.
So like when we first learned like continuity and stuff, like that's like typically like a removable continuity or discontinuity.
Right, we did removable, and we did the vertical asymptote, and the
So in
jump.
application, removable discontinuity means it's not continuous.
Any kind of discontinuity means, yeah, not continuous, yeah. So this would be an example of a potential removable discontinuity, for sure. Yeah, because it's not, it could be a jump, I suppose, which is not removable, because it could be this, and it could be that, possibly. But again, that's why it's important to say, hey, you got a differentiable function, so we have a continuous function, therefore we can do this limit thing. Okay. Question, Heather, maybe? Yes?
Does continuity imply differentiability?
No, other way around. Differentiability implies continuity. Yep. Any other comments,
So if
questions? Yeah.
differentiability means it's continuous, then if they've already defined that it's continuous,
You have to make the connection. You have to make the connection, right? So, and by making the connection, you are basically saying, I know that this is important, right? Versus like, oh, it's just random, and we're not going to assume that you knew. Yeah, we're not going to assume that just because you got to a good answer, you knew why you should have gotten there. Does that make sense? Just trying to examine your thinking more than just the result. Anybody else? Audrey?
So if it didn't say differentiable and you solved it, would you be able to do that, or would it be wrong?
No, because we wouldn't know what the graph of G looks like.
Okay, so if you solved it, you would get like no points versus like.
Well, they're not going to set you up for failure like that. They're not going to say, hey, find this, and then not give you enough information. Like if you bring up a good point. Like if you're ever doing some FRQ and your conclusion is there's not enough info, you're wrong.
Yeah.
Unless they've specifically said that that's an option, right?
Or no.
So they'll, like if that's going to be on the table, they'll say, hey, consider that it might not have enough information. I think that would be incredibly rare / never. But if you find yourself saying that, then you missed something. Like you didn't read something or you didn't see something.
Okay.
That was the answer last year. I remember the 3 responses in AP Physics.
Not enough info.
Information to solve, yeah.
Did they even like give you a hint that that was possible?
I mean, like you just like couldn't. I mean, I guess maybe if you like use the wrong equation. If you use the
Okay.
right equation, you just couldn't.
Have you guys flip over and try number 6? This one will probably go a little faster for you.
There's another.
So please try this one. We'll grade this in like 10, 11 minutes or so. So try to work efficiently. I think this is something that's at least part of it you've gotten a lot of practice with. So please check it out. This
Wait, can you
one.
tell if they recurred or not? And then you always say not to go over other tickets.
Yeah, certainly, oops, you want to try to avoid that. But yeah, so if you had, like if you went through the correct point, so maybe you did that, I mean, you continued on.
Yeah, no, I meant the top, like just the 2 ones have to be straight.
Yeah, I think so. What did you have? I was a reader on this one too, and yeah, so I think you would have been good, because that was our standard. Like, was the line a perfect ruler line? No. If there was some slight bend to it, but it looked like they intended it for it to be straight, then we had to make a judgment call. So probably okay, I would say. Yeah. There would have probably have been an argument about your paper if you would have turned that in. Yeah. All right, so then B was the equation of the tangent line. So the slope was 4/3. You got that, of course, by plugging the 1, 0 into your dy dx. Like you said, the point of tangency was given to you. And so then if you found your approximation, and of course, Audrey, go ahead.
I had a question. If you didn't simplify it and you just did like 4 divided by 3 times negative 0.3, is that okay? 'Cause
Yeah, that's what I was going to say. You could really stop right here.
okay.
You could have even stopped even a little further short than what you just said. You could have just said, the thing in the purple box, that's my approximation. You didn't have to take it all the way to the negative 0.4. So, okay. And then you can obviously see part of C right there. I'll scroll all the way up. It was worth 5 of the 9 points. So you had to separate your variables. I saw a lot of you had done that correctly, so that's obviously a good start. I hope none of you involved ln with that left side antiderivative. It was tempting for sure. But the squared, remember the squared is what messes that up. And then there were a couple of different varieties of forms of answers there, whether you tried to simplify, maybe you had a fraction within a fraction. There were a couple of different ways. And I would encourage you to do this. Like if you got, like I'm looking at Nick's, like his answer looks pretty similar to the final solution. What I would encourage you to do, because obviously we're kind of coming up against our time here, do a little algebra and see if it really did work out. See if you can add some, get a common denominator to add and flip and multiply and all that good stuff. Hopefully you'll see that it did work out well.
On the last one, you don't have to scroll back up, but when it was like for approximations, like I have a bad habit of like just using an equal sign. Would
Sure.
they count you wrong for using an equal sign versus like the squiggly one?
Usually not.
Okay.
Yeah, usually they just call that like a spelling error
Okay.
or something like that. So try to do it right, but I think you'd be okay. I certainly would not take points off your quiz for that. Okay, so once again, you've seen a good example of the things that I'm hoping that you're doing. So take some of your own time. The more time you spend to wherever, wherever the breaking point is, the better. You obviously want to get some sleep. But if I were you, I would be immersing myself in as many of these no calculator FRQs as I could throughout these next couple of days. So thanks for your good effort and attention. Head on down to the gym, right? It's the assembly today.
No drugs.
Mr. Anderson.